5.7, number 432. We have the definite integral from 0 to 1/2 of a pretty complicated looking object here, cosine of tan inverse of t over 1 plus t squared dt. So again, if we're going to do a u sub, let's start thinking about that which is parentheses, that which is parenthesized. So u should be tan inverse t, my inner function. Now it could be right, it could be wrong, but I'm saying it's always a good place to start when you see something like that. And this one, you can already tell it's going to turn out, but in general, always try to start that way if you are not sure. It's a good place to begin. The derivative will be 1 over 1 plus t squared times dt. So that is exactly what we have down here. And ignoring the cos composition above, we would have 1 over 1 plus t squared dt. So therefore, everything in t is now taken care of and can be replaced with something of u. So this should become something like cos of u du, right? The entire 1 on 1 plus t squared dt is just du itself, and we have cos of tan inverse. The tan inverse was u. So we have this. We just need to run these numbers through the transformation. This may not be so obvious. So you run 0 through tan inverse of 0 is 0. But 1/2, tan inverse of 1/2 is not a special angle, right? So we're just going to write tan inverse of 1/2 up here. So it doesn't work out to anything in particular that we're aware of. Tan inverse of 1/2, all right? Moving further. The antiderivative of cos is, of course, sine. So this is going to be sine u evaluated, according to the fundamental theorem of calculus part 2, at 0 and tan inverse of 1/2. All right, so this is looking a little strange at the moment that we have such an oddball limit of integration here, but it seems like it will work out. So equals, I'm going to write it below here, sine of tan inverse of 1/2 minus sine of 0 equals. Now we know sine of 0 is 0, so that doesn't play any role here. It's just this strange looking sine tan inverse of 1/2. So to figure this out, all we need to do is just draw a picture, or you can just think about it very hard. Right? But pictures tend to help in these cases. So tan inverse of 1/2 is some kind of angle, right? And that angle has to appear because tan inverse is trapped, tan inverse of x in general is trapped between pi on 2 and negative pi on 2 for its range. Therefore, we're somewhere in here. Okay? But since it's tan inverse of 1/2 equals theta, that implies that tan of theta must be 1/2 because of the idea of inverse functions, right? The output here is the input to the tan, and the input to the tan inverse is the output from the tan. So since tan is producing a positive 1/2 value, we must be in the first quadrant, not the fourth. Again, the first and fourth were the only two possibilities because of the natural range of tan inverse. And we're choosing the first quadrant to draw our picture because this was a positive 1/2 in here. That means tan of this angle that we don't know is going to be a positive 1/2 value, and you only get positive values for tan in the first and third quadrants. But since we're stuck between first and fourth, it must be the first. Okay. So I'm just going to draw an arbitrary picture in here. It looks like it's 45, but it's not. It's just an arbitrary drawing. But this angle is the mysterious theta that we're not going to figure out. The point is not to find the angle theta. The main thrust is that we know it's in the first quadrant. But if tan of theta is 1/2, we know tan is opposite over adjacent. So that means if I were to draw a triangle here, this would be opposite over adjacent. Oops, sorry, wrote that totally backwards. Sorry. Opposite over adjacent, right? So 1 to 2 ratio there. Now, that tan inverse of 1/2 is the angle that produces this 1 to 2 ratio here for tan. So therefore, sine of this angle, right, will be the opposite over the hypotenuse. So all we need to do is figure out the hypotenuse here, and we'll have our answer for the sine. Okay? So this answer is really sine of this mysterious angle that we're not going to figure out. We don't need to figure it out. We can bypass it using this method. So we're getting sine of this angle, theta, and it is, in this case, the opposite over the hypotenuse because we're dealing with a sine function. So calculating the hypotenuse here, it's obviously the square root of 4 plus 1, right? A square plus square, and we get square root of 5. So therefore, the answer must be 1 over root 5, which is the same as root 5 on 5.